Dinosaurs ruled the Earth for over 200 million years, until suddenly they didn't. But why? There are many theories about why they died out so fast. But which one is correct? We consulted with experts in geology and paleontology to bring you the ultimate guide to dinosaur extinction theories. What really happened? So get ready, because we're going to talk about asteroids, volcanoes, mammals, and more. First, let's discuss the asteroid impact theory. Scientists have long believed that an asteroid slamming into Earth was the main cause of the extinction of dinosaurs. This theory is supported by evidence found all around the world, such as iridium deposits and shocked quartz grains dating back to the end of the Cretaceous period, which all suggest a major extraterrestrial impact. The idea that an asteroid killed off the dinosaurs was first proposed in 1980 by physicist Luis Alvarez, along with his son Walter Alvarez, a geologist. They suggested that a large meteorite impact caused rapid climatic changes that led to the mass extinction. Their theory was based on the discovery of a thin clay layer containing high levels of iridium at the KT boundary, which is the geological layer that separates the Cretaceous and Paleogene periods. Iridium is rare on Earth, but common in space rocks. The Alvarezes hypothesized that the iridium came from a giant asteroid or comet that crashed into Earth around 66 million years ago. And this impact triggered devastating consequences for life on Earth. A lot of evidence supports the asteroid impact theory. For example, there are large craters that were formed around the world during the late Cretaceous period, such as the Lacustrine crater in Tunisia, the Shiva crater in India, and the Bolti Rocas in Mexico. These craters are thought to have formed as a result of meteorite impacts that occurred during this time period. However, the asteroid impact theory has also faced some criticism. Some scientists argue that the evidence for a single impact event is not conclusive, and that other factors may have played a role in the extinction of dinosaurs. For example, there is evidence that volcanic activity was high during the late Cretaceous period, and that this may have contributed to the mass extinction. Others have suggested that sea level changes and the breakup of the supercontinent Gondwana may have played a role. The asteroid impact theory gained widespread acceptance in the scientific community in the 1980s after the discovery of the Chicxulub crater in Mexico. The crater is roughly 180 kilometers wide and 300 meters deep, and is thought to have been formed by the impact of an asteroid or comet about 6 miles wide. According to the theory, the impact caused massive earthquakes, tsunamis, and wildfires, and ejected large amounts of dust and gas into the atmosphere. This blocked out the sun and caused drastic temperature changes that led to the mass extinction. The impact also caused massive climate shifts that led to the extinction of dinosaurs. The asteroid impact theory is generally accepted as the primary cause of the mass extinction at the end of the Cretaceous period. Most paleontologists agree that an asteroid or comet impact triggered a chain reaction of events that led to the extinction of dinosaurs. The impact caused massive climate shifts that led to the extinction of dinosaurs. The asteroid impact theory is generally accepted as the primary cause of the mass extinction at the end of the Cretaceous period. Most paleontologists agree that an asteroid or comet impact triggered a chain reaction of events that led to the extinction of dinosaurs. But wait, there's another popular theory that might also play a role. It's the volcanic activity theory. Another popular theory to explain the extinction of dinosaurs is increased volcanic activity. This theory suggests that large igneous provinces or lips, vast areas of igneous rock formed by the eruption of magma, played a significant role in causing the mass extinction. One of the largest LIPs, the Deccan Traps in India, covers an area of about 500,000 square kilometers and consists of basaltic lava flows that are up to 2 kilometers thick. The eruptions of the Deccan Traps began in the early Cretaceous period and continued intermittently until the end of the Cretaceous period. The timing of the eruptions coincides with the extinction of dinosaurs, suggesting that they may have played a role. Volcanic activity can cause mass extinctions through various mechanisms. For example, eruptions can release large amounts of gases and particles into the atmosphere, blocking sunlight and causing global cooling or warming. They can also release toxic substances that poison the environment and disrupt ecosystems. The Deccan Traps eruptions are estimated to have released large amounts of carbon dioxide and other greenhouse gases into the atmosphere, leading to global warming. This would have caused changes in precipitation patterns and sea levels, affecting the habitats of many species, including dinosaurs. Additionally, the eruptions may have released toxic gases, such as hydrogen sulfide, which can lead to acid rain and soil acidification, further disrupting ecosystems. Evidence for the role of volcanic activity in the extinction of dinosaurs comes from several sources. For example, there are many fossils of marine organisms that show signs of stress, such as elevated levels of the stress hormone cortisol, indicating that they lived through environmental changes caused by volcanic eruptions. Other evidence comes from the geological record, such as the presence of ash and other volcanic materials at the KT boundary. While the exact role of volcanic activity in the extinction of dinosaurs is still debated, it is generally agreed that it played a significant role alongside other factors, such as the asteroid impact. But here's where things get interesting. Not all species disappeared in the mass extinction. So while discussing the asteroid impact and volcanic activity theories, it's important to note that not all species were affected equally. Some groups of animals, such as mammals and certain marine organisms, were largely unaffected by the extinction event. This suggests that these groups may have possessed characteristics that allowed them to survive the environmental changes that occurred, such as the ability to live in a variety of habitats or to adapt to changing food sources. Mammals, for example, were small proto-wombats who were active during the night and ate plants adapted to surviving in the undergrowth of forests. This ecological strategy may have helped them to survive the mass extinction and eventually gave rise to modern mammals. Similarly, some marine organisms, such as foraminifera, experienced only a minor decline in diversity during the extinction event. These organisms, which are single-celled marine protists, were able to adapt to the changing ocean conditions and continue to thrive. In contrast, dinosaurs, which were mostly large, long-lived animals with specific habitat requirements, were more vulnerable to extinction. For example, sauropods, the largest group of herbivorous dinosaurs, were slow-growing animals that required large amounts of vegetation and may have been particularly vulnerable to changes in plant communities. Likewise, many marine reptiles, such as ichthyosaurs and plesiosaurs, were large, slow-moving animals that relied on stable ocean conditions and may have been unable to adapt quickly enough to the changes that occurred during the mass extinction. Overall, the mass extinction at the end of the Cretaceous period was a catastrophic event that had a profound impact on life on Earth. While the primary cause of the extinction is generally attributed to an asteroid impact, the role of volcanic activity cannot be ignored. Additionally, it is important to recognize that not all species were affected equally and that some groups were able to survive the event due to their unique characteristics and adaptations. Further research and discoveries will continue to shed light on the complex interplay of factors that led to the extinction of dinosaurs and other species during this critical moment in Earth history. So, what do you think? Do you think the asteroid impact theory or the volcanic activity theory better explains the extinction of dinosaurs? Let us know in the comments below. And if you enjoyed this video, don't forget to subscribe to our channel for more fun and educational content. Thanks for watching.